I'm Alan Ross. I'm the managing editor of APC Technologies, and we are here at the NETA, the International Electrical Testing Association, their 2023 Power Tech Conference, doing interviews. My guest with me is the Director of Communications for APC Media, Rachel Linke. Rachel, thank you so much for being here.
Absolutely, Alan. Would miss it.
We're just going to have an interesting time with all of these people, and tell me what you like best about these interviews.
The best part about these interviews, I feel like, is that it really brings about a lot of great thought leadership, and I really just love how you make everybody feel so comfortable, Alan. You really try to get people to just be comfortable and in their own skin, and then so much great information comes out of it. So
let's see if we made people in the next interview comfortable. Enjoy. My next guest is Kevin Maynard. Kevin is an engineer with
Potomac Testing.
I should have said that because it's on your shirt right there.
Yep.
I love the logo there. You can go back to your marketing people and say it was brilliant. But Kevin, you made a presentation here, but before we get to what you were talking about, why did you come into the industry? How did you come into this industry? And just a little bit about your background.
I actually came out of school with a degree in electrical engineering, and
I'm so sorry. Do you know what every electrical engineer calls a mechanical engineer 5 years after they graduate?
No.
Boss man, but I'm a mechanical engineer. No, a lot of double E's here, and we want to talk about the engineering, but you came out of school. Have you been working for Potomac the entire time?
So no, I ended up coming out and I worked for another NETA company at first, and things like that, and so I got my taste in the field, but then I started doing studies and things like that, and I kind of liked that, so I started getting more into the power system studies, did that for a number of years, and then jumped to a consulting firm, and then finally wanted to come back to studies and being more hands-on with the equipment, and so I came to Potomac, and I've been there for about 5 years now.
Okay. So I know your presentation was engineers and how do you make engineers and how do you, which is, we have a huge problem with people had not come into this industry, and the old guys are retiring or have retired, so we got this huge gap. But we have it at the trades level, we have it at the engineering level. Make a case for why people should go into EE and why they should come in this part of the industry instead of going into electronics and all of that.
Well, in terms of why to come into the industry, you've never met a poor engineer. A guy's always going to be able to put food on his table and things like that, always going to have a fulfilling career, a lot of challenges and things like that, very wide diversity. The other big benefit from a power system standpoint is that if you go into electronics, what you learn now is going to be obsolete in 3 years.
Yeah.
What you learn in the power industry now is going to be valuable in 30 years.
Yeah.
And so we get a much longer life expectancy in terms of our jobs and our careers and things like that. And those that have been in it longer end up having more knowledge and more ability to grow within it.
Okay. Give me a synopsis of your presentation here.
So the big thing that I go after in the presentation, I did it with my co-presenter, Professor Aaron St. Ledger from West Point Military Academy.
I think I'm interviewing him.
He's already on a plane. So.
Oh, okay. I'm not interviewing him then.
But he talked about the undergraduate curriculum and what's being taught now, and kind of how there's core classes, and then there's electrical engineering classes, and then there's power classes. So it's kind of building on. So when you're coming out, they go after the idea of learning how to learn more than anything, as well as a very real realization that coming out of engineering school, you're not a fully proficient engineer. So then comes to my part where I want to develop that engineer more. And the big thing that I wanted to go after as well was to make sure that the engineers that we develop stay with us. Because that is one of the big problems with newer engineers coming into the industry, is that they end up doing 3 to 5 years and then they're gone.
Well, they get poached.
They get poached.
There's a lot of poaching in this industry.
As well as they jump to other firms, other disciplines and things like that, like other tracks other than, say, like a NETA testing company. And so by training them and bringing a holistic view and giving them a more wider berth in the beginning to grow, we allow them to become the engineers they want to be.
Okay.
And we allow them to develop into somebody that can both not only do the work but sell the work. And so therefore they become self-sustaining within themselves, and that gives them more gratitude, more flexibility, more enjoyment and growth and benefit for their their careers.
So people who do the work and sell the work are selling consultancy. They're basically selling a trusted advisor.
Yeah.
That's what engineers are. We are trusted advisors. Now, I'm not trusted in electrical. However, I did stay at a Holiday Inn Express one time.
There you go.
But the idea that we become trusted advisors, speak a little bit about that, because that is the most rewarding career you can have. When the people that you talk to, you never sell, they're looking at you as that person that can help. Talk a little bit about that.
So that intimacy is one of the best parts of our industry.
Intimacy.
Yes.
Never heard that in the
You
industry.
end up
No, I like
developing a relationship with that person, and you become symbiotic relationship where it's a mutually beneficial. So therefore, they're getting something out of you, and you're getting something out of them. But by finding out what keeps your clients up at night and working on those problems, you become integral to how they run their facility, how they can achieve what they want to achieve. So their goals become your goals. And the long-term interaction that we have with our clients through NITA allows for that intimacy and allows for that relationship to develop, so that we're able to support that client through the maintenance aspects, and then use the maintenance aspects to help drive the engineering aspects, and then have it come full back circle so that the engineering is helping with the construction and design and expansion and things like that. And so when a client can come to you and you're essentially a part of their team, it's really cool. Like I'm doing a project for a large client, and we have free will to build the best system possible. And as a NITA engineer, that's an opportunity I'm going to get that a design engineer is almost never going to get.
So that's not a study. You're basically in a developmental role there, engineering developmental role, which is brilliant. You said you liked studies, or
Yes.
you got into talk a little bit about that. Arc flash studies, things like that, one-line studies.
So the basic idea is the short circuit coordination arc flash.
Okay.
Short circuit makes sure that everything is going to be able to deal with the available fault current that's present. Coordination, make sure the coffee pot doesn't trip off the main. And arc flash.
For me, it's the microwave.
There you go. And arc flash, if somebody's in front of the panel, make sure they're safe doing it.
Yeah, okay.
And then we can get into more in-depth studies like harmonics and power quality, motor starting, transient studies. It's any way you want to evaluate your power system, we can do.
Right.
But there's the three base ones that are kind of needed for general operation. The rest come into play when you end up having abnormalities in your system, like, hey, why did that trip? What's going on here? Why do I keep losing production?
So power quality studies are becoming much more important because power quality issues are growing. EPRI in 2001 did a report, and they talked about the billions of dollars of losses that we're going to have in industrial America because of power quality. That was 2001. Yeah. They didn't even take into account a lot of the grid edge things, wind and solar, and the fact that we've gone to an inverter-based grid and things like that. Do you do power quality studies?
Very much so, and I actually have a very interesting story about that. Was working at a lumber mill, and they had a problem where their PLCs were tripping out all the time.
Yeah.
And so they brought us in for doing a grounding analysis, which links into power quality. And we kind of look around and we find out that their connection point is on a painted piece.
Okay.
And so I asked them, how much is this costing you? And they say, so far this year, and we're in March, they were at $1.5 million.
Oh my gosh.
Their solution was an extra wire that cost them $50 and a scraper.
Okay, I want that as a case study, okay? And you don't even have to name companies. Your company could be named, but I want that as a case study in the value of power quality studies, because you had to find it, right?
Oh, yeah.
Figure out where it was coming from.
It's power quality is an engineer's dream a little bit, because you're finding and bringing together all the different information, and you become, there's a lot of satisfaction in it, because when you solve it, everybody thinks you're the hero.
So from the EPRI study, power quality issues are increasing. Why? Why does an inverter-based system or wind and solar and grid edge change, why does it increase power quality issues?
It comes out to that most of our loads and things like that were more sinusoidal.
Yeah.
As we moved and got more electronic, they become more non-sinusoidal. So therefore, that ends up having problems with a lot of the computer-based, because the computer-based ends up looking at the tracking of the sine wave. So if you get any type of variance in it, you'll get double zero crossings, which when computers see that, they throw their hands up and say, I don't know what to do.
Yeah.
So with power quality, there was a a time I'm working on an IEEE computer, and I go to shut it down. I get the blue screen of death. It says, "You don't have the power to shut me down." I said, "To heck I don't. I'm in the power industry," and I pull the plug.
That solves the power quality issue,
Yep.
but creates another problem. No, that's really good. Anyway, thanks so much. This has been brilliant. I appreciate it. And I do want a case study that we will publish in the future, because we're doing a whole issue on power quality and issues, and that would be a great case study. I want, because you're an engineer. Engineers are problem solvers. We wake up and you give us a problem and we're going to run to it, as opposed to run from it. And I love that. You've just presented that case very well. But thank you so much.
Pleasure meeting you.